As we watch this video, we are seated in War 225, but merely a few miles away, salty water meets fresh lake water. This is defined as an estuary. This may sound simple in theory, but the density differences of these waters, tidal patterns, and hydrology are what ultimately lends to an estuary's unique mixing dynamics. Imagine you just rented a boat to cruise from Lake Union to the Puget Sound, our nearest estuary. You cross the Ballard Locks run by the Army Corps of Engineers and eventually make your way to Shoal Bay. You put on your scuba gear and dive in. You just jumped into a mixing zone. Your flippers didn't cause this mixing, but rather the physical interactions between two distinct water types did.
Here's a simplified side view of estuary mixing. The arrow can be signified by the fresh water from Lake Union, which is sourced back to the Cascade Mountain snowmelt. This is fresh, less dense, and thus floats on top. Meanwhile, salt water from the Pacific Ocean creates a wedge where it pushes against, forming a stratification line. This is due to the density differences. In fact, ocean water is only about 2.5% heavier than fresh water due to its salt content. Density first drives stratification in estuaries, but can be influenced by temperature differences in the water column to cause mixing. This contrasts the atmosphere, where temperature actually drives the formation of stratification. How much mixing actually happens in an estuary depends on two competing forces: river discharge pushing fresh water seaward, but then also tidal energy pushing salt water inland. When river flow is high and tides are weak, the layers stay separate. This is categorized as a stratified estuary. But when tidal energy dominates, the boundary breaks and the layers blend and mix. This is defined as a well-mixed estuary. Puget Sound sits somewhere in the middle, making it a partially mixed system. What hydrologic principles actually go into mixing? Tidal forces drive differential velocity between the buoyant freshwater layer and the denser saltwater beneath. This generates an interfacial shear at the density boundary. This is similar to the shear stress felt at a basin's bed versus the water on top. When the ratio of buoyancy to shear forces, quantified by the Richards number, falls between the critical threshold of 0.25, the interface becomes unstable and turbulent, developing eddies. These eddies entrain saltwater parcels upwards across the density interface, driving vertical mixing and progressively eroding the stratification. Lastly, it's important to note the bathymetry, also known as the topography of a basin, and how it influences vertical mixing and turbulence. In the Puget Sound specifically, sills, which are underwater ridges, promote turbulence and vertical mixing of denser seawater to the fresher water from Lake Union. Estuaries are where fresh, salt water, and hydrology meet. I hope that this 3-minute video informed you about the estuary nearest to us.